to our group meeting today. I think it just started. We have a special guest today on our show, Adam. And we're just going to run through the preparation activity, I guess. So do we want to go over the stuff that we did on our own part one, or do you guys want to just go over part two?
I don't really care.
Do you want to go over part one because it was confusing?
Sure.
All right, so use the information provided in the reading assignment to complete these questions. What is a confidence interval? Were you able to figure that one out, Scott?
That?
Were you able to figure out what a confidence interval was?
Yes. I I went on the reading and was looking at the confidence interval and didn't really find like the set definition of the confidence interval, but basically the best definition that I found on there was that it was the interval of numbers which estimates a population parameter.
Yeah, that's what I put is a list of numbers that like estimate a population parameter. So
because when I was looking on there, normally before or after they put the definition, the word is in bold.
Yeah, but they didn't have it on this one.
Yeah, they didn't. It just said, we'll explore how to create a confidence interval. And I'm like, all right, well, that's not the definition, but cool.
Yeah, let's do it.
So.
All right, cool. All right, number two, what is the margin of error in a confidence interval when estimating the population mean? The question is not asking for the formula, but rather what length it represents in the confidence interval. So margin of error is like half the width of a confidence interval. That's what I got from the reading. And it basically tells you that when you're within one like confident, or when you're within one margin of error, then like depending on the parameter size, if it's a large parameter, it's going to be large, and if it's small, then your margin of error is going to be smaller, kind of thing.
Makes sense.
Sorry, quick question. Did you guys say you're on lesson 10? So you're doing the group meeting quiz 10?
We're not the homework.
Oh, you're doing the homework.
Yeah.
Yeah, we usually run through the homework before we start the quiz. Sorry about that.
I got you.
Make sure we're on the same page.
I was so confused. So you're doing you're going over the homework quiz?
No, the homework. Just if you go over
the individual prep.
Okay.
Because they ask. Sorry, yeah, they ask us to do number one on like our own. Oh, this one just says, once you finish doing complete questions of part two. Usually it said like for part two, like complete in your groups. Is it just like we're just supposed to do the group quiz together?
You can't. You are supposed to do the group quiz together.
Yeah.
Right.
I actually don't have access to the prep assignment, so
dang.
At least I'm not seeing it here. I'll keep looking, but I'll go ahead and mute my mic again and leave you guys to it.
All right.
No problem.
If you want,
I'll like red flag, red flag, red flag. He's like, what's going on here? Awesome.
Here, one sec. I'll send them to you. I downloaded them, so they should be. I'll put it in the same one that I sent to you for the link.
Okay, cool.
All right. I just sent them to you. They're just 2 Word documents, so I promise I don't have any viruses on my computer. So.
Cool. All right, I'll take a look at those.
All right. Where are we at? All right. So We just usually go through the tricky ones, like the tricky homeworks or preparation assignments together, just because sometimes they're complicated or we don't understand one of the parts, so we just get someone else to like clarify for us, kind of thing.
Gotcha.
Okay, assuming you know O with a thing on top of it. What is the general formula for a confidence interval used to estimate the population mean? Okay.
The formula for it?
Yeah, I think it's asking what is the general, how do you calculate a confidence interval if you know?
I think I'm looking at it on the homework right now. It looks
Wait.
like it's
Is that the mean?
what the mean?
The little circle thing?
Standard deviation.
One sec. Right, sorry.
It looks like, I think I'm looking at it on the homework. It looks like it's the sample mean, which is the X with the line over it, minus the Z-score times the standard deviation divided by the square root of the n of n. And then same thing, but instead of minusing that, it's adding. So, or instead of subtracting, it's adding. Is that the formula? Because I'm looking here with, it gives an example in 4.1.2, the worked example, rolling a die 25 times. And it has, gives the mean and all that stuff, and it's got the formula right below it. I think that's it.
Hey, Adam, I think he's asking you for clarification.
Oh, anybody really? You see 4.1.2 in the reading?
Oh, 4.1.2 in the textbook?
Yeah.
Let me go there real quick.
I put it on I linked it in the Google chat in our chat room here. I'm pretty sure that's the formula.
Yeah, that's the formula. It looks like it.
Man.
4.1.2. Yeah, that's the formula for the confidence interval. What number? I just barely pulled up the assignment.
We're on number 3.
Oh, okay. So, assuming you know sigma, what is the general formula for a confidence interval used to estimate the population mean? Yeah, that's it.
Okay.
The x bar plus or minus z times sigma over the square root of n.
Yeah.
Okay.
Oh, by the way, that's what that symbol is. It's sigma, and it's the standard deviation.
Sigma and standard deviation. I've just been like assigning. Yeah. Okay.
I don't know like the legit names for all of them, so I just say standard deviation. So sigma.
Yeah.
All right.
Sigma. Yeah, it sounds more legit.
I know it does. It sounds more mathy. And that formula looks familiar. The standard deviation divided by the square root of n. Did we see that somewhere else? Did you use to calculate something else?
You saw something similar to that for
Standard deviation with a population.
Oh, is that for calculating the mean where you do x divided by the square root of... Oh, no, that's calculating standard deviation. It's
When
the
you-
mean divided by the square root of whatever the freak that is.
Yeah, the standard deviation. Yeah.
maybe are you thinking of calculating z-scores when you do x bar minus mu divided by the standard deviation?
You know you're using.
Yeah. That's what I was thinking about. Okay.
Okay.
So obviously not the same thing. I thought I'd seen like that specifically the standard deviation divided by the square root of n somewhere to calculate something, but
Yeah. If you the standard sigma divided with sigma is the population standard deviation. If you divide sigma by the square root of n, that is the sample standard deviation.
the square root of n.
No, when you divide
I see.
yeah, when
So
you
the
divide.
sample.
So fun fact,
Gotcha.
in fact, I've never seen it not this way so far. but whenever you have a Greek symbol like sigma, nothing else is coming to mind all of a sudden. Oh, mu, the little u thing.
Okay.
That one's called mu. Whenever you have a Greek symbol, that usually denotes something about a parameter. So something about your population. Whenever you have a something that we're I don't know what they're called.
N or whatever.
Yeah,
for
like
the
N and
population.
X and things like that. That usually denotes something about a statistic. So sigma is a population standard deviation, but when we try to find the standard deviation of our sample, then
It would be the square root. You divide that by the square root of n.
yeah,
So if you wanted to find the sample mean, would you also divide that like by the square root of n? You take the mean for the, the population mean and divide that by the square root of n for the sample mean?
well, for the sample mean, I mean, you have a sample. The sample?
Yeah, that's right. You only need to do the sample mean like that if it's skewed or something like that, right? Or what's it called?
Well, if you're trying to find, are you talking about the z-score again, or?
I don't think so. Man, this lesson in particular has got me all sorts of lost. Seriously.
No worries, we can work through it. I mean, a mean, when you have a sample, like if you have 5 numbers or 5 observations,
Mm-hmm.
when you just take the mean of those 5 observations, and that's your sample mean.
Right.
And we're using the sample mean to estimate what we think the population mean is. Does that make sense?
Yep.
Yeah.
Fair enough. Man. All right. We'll continue to trudge on. What do we got next?
Number 4. So what are the assumptions for creating a confidence interval for a single mean with sigma known? So that means that... Oh,
sorry, I was just going to say, that's funny that they spell it out that time instead of putting the symbol.
Yeah, I know, right? I wish they just, for the first couple chapters, just had like sigma and then like in brackets, like the little symbol for it. It would have made... clarifies a lot. But so I read when I was reading the chapter, it said something about like when it is like when you create assumptions for a confidence interval, it's that you're pulling like random samples from it and that it's normally distributed. Those are like the 2 main things I got from it.
Okay.
Does anyone have anything else for figuring out like a confidence interval with a single mean with sigma known?
That sounds about right to me.
Cool.
Okay.
And then plugging this stuff into the normal probability applet, type in 0.9 for the area, shade in the middle area, under the curve, leading the 2 tails unshaded. So that was pretty straightforward.
Yeah.
So I got 1.645,
Yep.
1.96, and 2.576.
Yep.
So it's pretty...
I like that he gives us the answers for the preparation assignment because I almost work backwards sometimes. You know what I mean? So it kind of helps me when I work backwards and I'm like, okay, this is the answer, but I got this. How did, where's the miscalculation? Then I just see myself improving,
Yeah.
Yeah.
I like that he does that.
Yeah. Or like just like immediate feedback. It's like you do it and then you like check it. And yeah, it's super.
Agreed.
All right. And then what happens when the z-score is the area in the middle under the normal curve increases? The z-score also increases because it's going further away from the mean.
Yep.
Yeah. So.
Great.
All right, what are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? You need a random sample. It needs to be normally distributed, like we were talking about before. And then I didn't catch the last one. Like we're
What are the
supposed to
three
know
assumptions that need to be checked before you compute a confidence interval for a mean?
Yeah. So the two are like the same from question 4. But then
Would they all be the same?
I only know 2 of them. I didn't get the third one.
Hmm.
Did you guys get the third one?
Well, it just says that it needs to be assumed to be known.
What assumes to be known?
Sigma.
Oh,
Oh, it's right here. In 4.4 in the reading, I think.
let me see. 4.4.
Yeah, 4.4 in the reading, I think.
Oh, yeah. Here it is.
I think that's what that's supposed to be.
Yeah, those are 3. They're telling us to watch a video for this. Oh, they pull that too. I don't know.
Yeah, I think I'm gonna have to watch all the videos for this one too.
Yeah, I
I
was
did
just
last
like,
week since I wasn't at that one.
yeah.
All right, now we're on to the fun stuff.
All right, the GMAT is used
Calculations.
as an admission thing. They use this a lot.
Mm-hmm.
What does the point estimate for the population mean? The point estimate?
Hold on.
Do you guys? This one? I got it. I don't have the answers up, but
I put 541.
541. I got 1.65.
For number 7?
Can I tell you a secret?
Yes.
A point estimate and a mean is the same thing.
Oh,
Or
Wow.
excuse me, a point estimate and a sample mean. I should clarify that. A point estimate and a sample mean are the same thing. A point estimate just
okay.
all that means is we are trying to estimate the true point.
Gotcha.
Okay.
So because
So-
it's a sample mean for 50 students, and that's the sample mean is 541, the point estimate
Exactly.
is 541.
Yep.
Okay.
Okay, cool.
Just trying to teach you terminology
Well,
is all.
If it's a sample mean over 30 people, isn't the sample mean going to be the same as the population mean?
Not necessarily. The larger your sample, the closer you'll get. That's what the law of large numbers states.
Right.
But it doesn't necessarily mean you'll hit it. That's why we need confidence intervals, because then we can say we're whatever confident that we're in the range. You know what I mean?
But
Yeah.
as your sample goes up, does that mean that the margin of error always goes down?
Correct. Yeah.
And
Yeah.
that's the law of large numbers, like you were saying?
Yep.
Okay.
Okay.
So is that even true if you get like crazy outliers, like that just like are all like a 2 z-score and like a negative 2 z-score, just like totally like out there? Is it kind of like flipping a coin, like as you flip it more and more times, it gets closer to being 50 heads, 50 tails?
Yeah. I mean, that's the thing with statistics like this. There's always a chance that you're going to, I mean, if I draw a sample from a population, like for example, if I'm drawing a sample of men and I want to measure their height,
Yeah.
it's entirely possible. I mean, I would guess that the true mean in the United States is probably like 5'9", 5'10", something like that. It's entirely possible that I draw a sample and 100% of my sample is above 6 feet tall. And that's just the nature of statistics, and that's why we use confidence intervals,
Yeah.
is because it allows for a margin of error.
So is that why, like, say it's like the average height in the U.S. is like 5'10" plus or minus 2 inches? Is that, and like the
Yeah.
more people you do, the plus and minus is gonna get smaller and smaller?
Yep, that's correct.
Okay. All right.
Yeah.
This is clicking. Okay. All right. Question 8. Create a 95% confidence interval for the population mean. Show your work below. I just got 532.
Can we do that out?
Huh?
Can we do that out?
Yeah, sure.
So 95%, the z-score is 1.96, right?
Yeah, correct.
Okay. So it's the 541 minus
Yeah, so you have to minus it and then
1.96 times the standard deviation is 32 divided by the square root of n, which is 50.
Yep.
And then it's the same thing on the other side, but instead of instead of subtracting, you're adding.
correct.
Okay. I just had to make sure I wrote that out. So
Guys,
feel like
are there Excel formulas for a lot of these? Because I have the hardest time remembering all of them.
Yeah, I've been using Excel formulas for like all of these because I took accounting 333 and they like teach you like all these Excel shortcuts.
Okay,
Yeah,
so
but
when
they
in
don't
doubt, use Excel.
That's what I've been doing. Like I try doing it out sometimes, and sometimes I just like try to compare it against the ones I did in Excel.
Okay.
How would you do that though? They don't have a formula for anything like this, do they?
For z-score,
Yeah.
I'm pretty sure they do.
You have to have an array for the z-score. And we don't have an array for it.
Let me check. Nothing statistics.
Adam, when you were taking this class, you said you did quite well. Like, what helped you out the most as you were going through the assignments? Because for me, like the homework assignments, I feel like are my biggest like things that I get stuck on.
Oh, can you hear me?
Yeah.
Yep.
Sorry, I muted my mic and wasn't sure if I unmuted it. Anyways, I don't know. You say that you're having the hardest time with the homework assignments?
Yeah.
Man, I don't know if I could pinpoint one specific thing. I mean,
Maybe just review materials more, take more time.
Yeah, in fact, that's what I was going to say. The online textbook is a really, really good resource. I would also recommend. I don't know. Oh, man, I don't know how to do this. The formulas, like the formulas that we're learning about right now, they are really important. But more important than the formulas is understanding the concept.
Okay.
So, like, I'm just trying to think of how to word this. Well, like for example, if I with the confidence interval, the x bar plus or minus z times the standard deviation over the square root of n, z times the standard deviation over the square root of n, that is the formula for the margin of error. So I mean, this is just one example, and it's probably a poor example too. But if you just understand or practice that, I guess, and recognize that, so when you see that formula, z times the standard deviation over the square root of n, and you know, oh, that's my margin of error, and just think about that, like how that fits into the puzzle. I mean, I guess it'll make more sense as we go over some more of the questions. But I don't know. I don't know if that helps, but just go over the material and try to understand it conceptually a little bit. But
okay, sounds good.
There, well, at least that chat gave me time to kind of work out this section by hand, and I got it. So I think I'm okay. All right. What's the next one? Number 8. The answer is 532.13 and 549.87.
Yeah. So I don't understand. Like, I think some of the things I did wrong in the test was just like rounding errors,
Yeah.
And I feel like sometimes they specify like how many decimal places they want it to. And then other times it's just like they're just like enter the percent that you got, or just like it doesn't specify how many decimal places it's rounded to. So as a good rule of thumb, just like 2 decimal places, or it seems like in some places they use 3. So like if it's not stated, do you know which one we're supposed to use? Evan?
It's usually 3 unless it's stated otherwise. It's usually 3 decimal places.
Okay. And
And
did I just not read the instructions carefully enough?
It should say that at the top of most of the lessons. All the ones that I've seen so far will say at the top to use 3 decimal places unless otherwise stated. But yeah, you definitely have to watch out for that.
Yeah, Adam, if we did things on the exam and they were rounding errors, can we write and have Brother Bennett check that?
Yeah, I mean it's worth a shot for sure. If it was so you're saying like if it said in the instructions to do 2 decimals and you did 3 and got it wrong because of that, is that what you're saying?
Yeah.
Yeah, shoot him an email. I mean, there's no guarantee that he'll give it to you. If it were me, I'd give it to you.
Well, I think so, Adam.
But yeah, give it a shot.
Cool.
Okay. I'm working out the next one already real quick. It's actually pretty easy. Just same thing except for n changes to hundreds. Which is nice because that's 10. Okay.
So how much more intense does it get after you get like into statistics? Like what is intermediate stats that this like intro stats isn't?
It's the more I learn, the more I learn there's more to learn.
Yeah, because like right now it seems like there's kind of like a finite things you can learn, but I guess you can make all sorts of different inferences. Right.
Oh yeah, there's I mean, just go to a library and pick up a book about different statistical methods, and it's insane. Yeah, once you get into like ANOVAs and MANCOVAs, there's even non-parametric tests that don't. So like you can do tests based on ranks instead of based on measurements. Like there's a lot. It's really cool. I highly recommend it.
I guess that's why there's like how many exams? Like 12 exams to become an actuariist.
Yeah.
What's that?
There's like 12 is that why there's like 12 exams to become like an actuarial scientist?
12 exams for
like, do you know what an actuary is? It's like someone who like calculates insurance rates or whatever.
Oh, okay.
Basically his wife, Michaela.
No, that's not me.
My wife just changed her major to data science. It's like the new degree that they're offering here.
Oh, nice.
Similar.
That sounds really interesting to me, actually.
Yeah, it's like a mixture of coding and stats.
Gross.
Yeah. Does she use R?
I don't know. She's still in. Yeah, she hasn't taken intermediate yet.
Yeah, I haven't taken anything yet. I'm still taking biology right now.
Yeah, she's still like in like a human bio major, but her teacher, who's it, Brother
Hathaway?
Hathaway, just convinced her to change her mind.
Nice.
Yeah. All right. So,
Okay.
yeah.
The next one is 534.728 and 547.272.
Boom, carrying the team.
So I did it all by hand just to make sure, because like when I do stuff by hand, I feel like I know it from that
Yeah.
point forward. So all right.
Onwards and upwards to the quiz.
Yeah.
Sure. I feel like I'm good.
Let's do this thing.
Okay.
All right, 1 and 2 are true. Helps you guys out.
Oh, hold on a second.
Can't you retake
Is it the reading?
It's
How do you know I completed the individual prep? Maybe I
because
did.
you live the honor code. That's how I know.
Yeah.
All right. Okay.
All right.
Find the margin of error for a 90% confidence interval when the standard deviation is 50 and the population is 25. Okay.
All right. So I just typed this into Excel, confidence.norm, and then just typed in the things, and I got 16.45.
Really? Is that it?
16,
Yeah.
but if we're running it to 3, Darren, does it become 16,449, or are we doing the 4.5?
I think because that, like, the third decimal place rounds it up. So it's like,
Okay.
yeah.
How do you actually hold on? Maybe that's it. 1.256613. Is that what
Yeah.
you got? Really? I didn't know about that. That's a new formula I learned. What was it called again?
It's
Confidence?
confidence norm.
Holy cow. That's awesome. Let me write that down. All right. Talk about getting A's on the exam.
Yes.
Okay. Confidence.norm. 0.9. Yep. All right. We're good.
All right. Okay, so then the next one, which of the following statements is true? Okay, so standard deviation is the interval estimator of, no.
Okay, what was it? Which of the following statement is true?
Guys, I had a hard time on the homework doing like the English version of it. Do you know what I mean? I think that goes back to Adam just explaining to understand the concepts more of what they're actually doing behind the scenes kind of thing.
So is it the third one where the population mean is a point estimator of the sample mean? I think that's correct because you remember Adam was talking about, where is it at? In that example with the GMAT scores, that the sample mean for the students, for 50 students, was 541, and it was the same as the point estimate for the population mean. So I think that's right.
You're close.
Oh, is it the other way around?
Yeah. So if you said that mu is a, well, actually, let's see. No, you wouldn't be able to say it that way. No, X bar is a point estimator of mu.
Okay. So
You're trying.
mu can
Go
never
ahead.
be a point estimator, right?
No, because mu is the population parameter, or the population mean.
Gotcha.
Sorry.
Also, he's the 151st Pokemon.
That's fair. All right, got it. Well, that was
So
close.
that's why I think about every time I hear that. It's like, meow. It's
I
like,
know, that's what I
I'm
think too.
7 years old again playing Pokemon cards.
Good old 90s.
Well, thanks to
All right.
Pokemon Go, that's what everybody's thinking all over again.
Oh
Yeah,
my
seriously.
gosh.
We're going B then, Adam, is what you're saying. It's actually reversed, and we're going B instead of C.
Yeah, it's B, yeah.
mean
X bar is a
okay.
point estimator of mu.
Yeah. So mu in practice in the real world, we almost never know mu. So
Right.
X bar is what we're using to try to estimate. What
Well,
it
why
is.
would you ever know? Like, what instances would you really know? Like, if you're
You
trying to
can't ever
calculate.
know Mew. He's mysterious.
Yeah.
Well,
I mean, I guess if your population is super small for some weird reason, I don't know. But I'm thinking like on the grand scale of like U.S. statistics, there's no way you could ever really know.
exactly.
Yeah.
I mean, the only way you'd know mu is if the population of interest is sufficiently small enough that you can actually measure it.
Yeah.
For example, if I wanted to know the mean height of everybody in one of my classes, I could easily go measure them all and get the mean height, and that would be mu. That wouldn't
Sure.
be a sample anymore. But
Sure.
if I just decided, well, I'm going to take a random sample of 5 of the students in my class, get a mean, and estimate what mu would be. Do you see what I'm saying? So
Yep.
that's the difference between x bar and mu.
Gotcha. Fair enough. All right.
Right.
Well, number 5. What's point estimate for the true GMAT score?
I found it's 526.
Yeah.
526.
That is a good trick. That is a really good trick.
Yeah.
Yeah.
All right. What's the margin of error for the 95% confidence interval for the true GMAT score?
So if you go to confidence norm, do that again, equals confidence dot norm. And then do 1 minus whatever we're looking for. So we're looking at
Wait, what?
95.
Oh, yeah.
So you do 1 minus 0.95. Then the
Right.
it asks you what the standard deviation is. And the standard deviation is
113.
113.
And the size is 64.
Pops out like a
So,
champ.
27.685. Nope. Yeah, 685. Oops. Okay. What is the lower limit of this confidence interval? What's the lower limit of the confidence interval?
So guys, I got for
right.
number 6, I got 27.685, right?
Yes.
Okay, and so I've got
For number 6, right?
yeah.
Okay.
And then for number 7, I was confused on this one, but I got 498.315.
I haven't done this one yet, but give me
I
just
got 498.315 as well.
Okay.
so it's 526 minus 95%, which is 1.96. Okay. Actually, I already did that up here, basically. All right. So what'd you guys get?
498.315.
Yeah. So
Enough
actually, for number 6, I got 27.685. So are we rounding that up because it's
I
4.5?
think so.
But if I round it out one more decimal place, it's 449. So I think we rounded down.
Hold on.
I
We
would
could just do it for funsies.
For number 6,
I would if you do this calculation using the formulas that they give you in the textbook, you get 27.685.
okay.
So that's something to keep in mind. They do expect you to use the formulas from the textbook, and Excel sometimes calculates things slightly differently, so be careful with that.
Okay.
I got 498.315. Is that what we put?
Yeah,
Yes.
that's what,
Excellent. Okay.
Thanks for the tip. I've been, maybe that's what bit me in the butt last test. I don't know.
Wait. Is number 6 wrong?
No, you got it right.
Okay.
No, it's right. It's right.
Good. Okay. What's the upper limit? Oh, well, no, I just do the same thing.
I got 553.685.
553 points. Yeah, 685. Yes.
553. Yep.
All right. Then what would happen to the width of the confidence interval if GNet increased the sample size?
Decrease.
It would decrease, obviously.
Change it to 99% confidence interval.
It would have to increase.
Yeah, it does. Yeah, because the area. I mean, obviously, the area is 95% up to 99% increases. Okay, Bright Bulb Light Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Oh, now we have to use good old algebra. So they're looking for the sample size.
Yeah.
Okay. Hold on.
Oh, goal seek in Excel, yes.
Oh, I forgot about goal seek. Oh, God. Yeah, I forgot
Goal
about that.
seek. What's that?
Goal
it
seek.
basically will try every single number that I can think of until like your bot, like whatever cell. So I'll do an example in Excel, real quick.
I forgot about that. Good thing.
So it's okay.
I see a foot behind your head.
Yeah, that's my wife's foot. She is-
Oh,
she's-
okay.
This
Hey.
week. I'm feeling so sick, Darren.
All right.
Yeah, I'm getting a cold.
Oh, that sucks.
I know.
I can't remember where goal seek is. Is it under data?
Is what under data?
Goal seek? Where the heck-
Yeah,
I can't
it's
remember.
under data. So you go to data, and then you go to what if analysis. and then you-
Yeah, that's right. There it is. And we're looking for N.
Yeah, so we're trying to set the population size. So I'll see if it works first, and then so we want a 99% confidence interval.
Oh yeah, it's got to contain a formula.
Yeah, I'm actually not sure if you can do it this way.
I'm gonna try because I have to put the formula in first. This would be cool if you could do this because I'll just save the spreadsheet and then use it this way from now on.
Mass distribute it for millions.
Okay. They want to assess the average life expectancy of their light bulbs. You know, standard deviation. All right.
So you just want to set it to 50, right?
Yeah.
50 hours, you mean? Is that what you're saying, Darren?
Yeah, so you want to set it. You want the margin of error to be 50 hours. So you want okay, let's see. So
Wait a second. Wait a second. I'm a little confused. Because we don't have the mean for this, do we? They have the standard deviation. They want 95% confidence interval. Oh gosh, what the heck do I do? How do you calculate that without the mean?
set so that
Is it? Do we have to get the mean first by doing?
Oh, it can't find a solution, so I don't think you can do it that way.
Darn it!
That's too bad.
Huh?
They
So
never
how
said-
do you do this?
you just have to work backwards, I guess. But so would you have to? You'd have to raise it to the power of 2 instead of square rooting it. So it would be.
But we don't have the mean to calculate this.
So you actually don't need the mean for this,
Okay.
because all they want us to find out is how big does our sample size need to be if we want to be within a margin of error of 50 hours.
Mhm.
So if you go in your textbook, in section 5, so if you remember the formula for the margin of error was m equals z times the standard deviation divided by the square root of n.
Yep.
So we know what margin of error we want, 50 hours. We know the z-score that associated with a 95% confidence interval. That was 1.96, I believe. Yep. We know sigma is stated right there, 400 hours. So now we just have to solve for n. In section 5 of the textbook, it gives you a formula that is already solved for n, which is n equals z times sigma divided by m, all squared.
Which is, okay, let's see. So you calculate m.
Or do they mean population standard deviation? No.
What? Man, I remember knowing what m was. Isn't m just the mean?
No, m is margin of error.
Oh,
Mean-
duh.
Yeah, mean is
I
typically
even wrote that
denoted.
down.
Yeah, mean is denoted with x bar for a sample mean, and
Right.
mu for population mean.
Gotcha. Okay, that's why I was confused. All right, so we have 50 equals 1.96, and the standard deviation, which is 400, divided by the square root of n. So it's 50 divided by 1.96, which is 25.5102, whatever. I'm going to do it in Excel so I don't have to worry about rounding. Okay.
And if you go look at the online textbook under section 5, it
Mhm.
gives you the formula.
I saw
And with-
that, yeah.
Okay, yeah, with n already solved.
So 50 divided by 1.96, and then you take and multiply. So it's going to be 400 divided by 25.5 something. And then you'll have the square root of n equals 15.68. And so you do the square root, or
Yeah.
so
No,
to
you
the power.
square it. Yeah. So I got a number. I want
To the
compare
power
it
of what?
to square root.
Oh,
To get rid of the square root, you
I forgot.
Darren, did you get 246 as a whole number?
I have, without rounding in anything, I got 245.8624. I did it in Excel, so there's no rounding.
All right, yeah. So I think it's 246 because you rounded up.
To a whole number?
Yep, you can't get
I
half
got
of a
246.
sample.
That makes sense.
Or if it's a little person, or like
You
a
either have the
Half
sample
of
or
the sample.
you don't. half of a person,
Funny.
or in this case, what is
I just learned about that in like American foundations. What was it? It's like the 2/5 or something, 4/5. I don't know. Something about how like black people's votes counted.
Oh, yeah, back in the day. That was crazy.
That was ridiculous.
Yeah, I learned about that. I was like, "What is that? Are they serious? Like that actually is a thing?"
Hey, if you think about it though, in the historical context, it kind of makes sense because it was a compromise between people that didn't want it and the people that did.
That's true.
Yeah.
Was it the 4/5? Yeah, it's 4/5 compromise, right?
Yeah, I think so.
American history is funny.
That's
Yes,
right. Even though you're
but-
Canadian, you like that American history.
Well, we have to fought for no taxes, and
Yeah.
then they got taxed to fight against the South and the North, and England. I don't know. I don't get it.
All
But
right.
anyways,
There you go. All right, now question 12. What is the lower limit of this 95% confidence level? Okay.
These last three were tricky for me, guys. I was kind of reading over them.
They are kind of tricky. Okay, simple random sample. 110,000 minus.
Wait, is it 110 or 111,000?
111. Whoops, my bad. 111,000 minus the z-score. So for 95%, that's 1.96 again. Standard deviation, which is point. Oh, 36,000.
Hey, David, have you done this one?
No, this is the one I need help with.
Okay. I got 99,002.
Okay.
Sorry, go ahead, Scott.
No, you're good. Okay, and then.
Darren, did you Excel this one or did you do it by hand?
I did in Excel. So it's probably wrong.
So 99,002.
Mm-hmm.
I got $99,001.53, but to the nearest whole number, 99,002.
Yeah. Cool.
Smooth move, Darren. Smooth move, buddy.
Look at me go. I freaking love Excel.
Yeah. And then, of course, the upper limit is going to be 122,999.
98.
But you round it up because it's 0.5.
No, go out one more decimal place, I think.
Oh, right. Yeah. You're right, because it's 0.466666666, whatever.
Yeah.
Yep. You are correct. I should have fixed that in Excel. Okay. There are 3 requirements that need to be checked when computing a confidence interval for a mean.
All of the above.
Yep. Very good. I'll
Yeah.
submit. I'll submit first. Hold on.
Okay.
Just make sure we're all good. We missed one of them, or at least I did.
Which one?
Number 3. What'd you guys put?
Yeah, we need that 9 on there, guys. That's what I was worried about.
Oh, what did you guys put?
Wait a second.
We put it was 16.459, but we just rounded it.
Wait. For question 3?
Yeah,
Yeah.
wasn't it the one Darren and I Darren, we just put 2 decimal spots instead of 3. I think it was supposed to be 16.459, but we put 45.
Why the heck did I put 1,257? I think I meant to put 1.257, but I think I put. What the heck was I thinking?
I don't know.
Darren, so Darren, when you submit, did you get the 45 right?
I'll submit it right now. I think he just submitted the wrong number, but we'll see.
Oh.
I did, yeah. No, that's what I'm saying. I submitted.
Okay.
Yeah.
So you have to do
the-
1 minus the contra, like, for when it says, when you put confidence norm, in brackets, you have to do 1 minus whatever the confidence interval is, and that gives you alpha. And then alpha, and then you just put in the mean, or what do you have to put in?
Should tell you a neat trick.
Yeah?
So you know what the z-score for a 90% confidence interval is, right?
1.645.
Correct. And so the rest of the formula is sigma divided by the square root of n. Well, the square root of n in this case is 5, and 50 divided by 5 is 10.
10, so 16.45.
Yep. Yeah. If